Today we are going to solve our paper Pearson Edexcel International GCSE 9-1, Monday 19-2025, most latest paper over there. And here it is 4CH1, 1C, SD0, 1C over there. Okay, before starting the paper, I really request you kindly subscribe my channel and share the video, like the video and comment the video if you are feeling any confusion in any question over there. I will upload the explanation. If you have some confusion in the form of read or directly, will send the link in the comment over there. Okay, and today we are going to solve this paper, which is having 110 marks over there. And I will say here, let's start now. Okay. Let's start the paper here. In the start, the periodic table is given, and here is the paper, all right. Okay, the diagram represents the structure of an atom, represents an atom of an element over there. Here he is saying different labeling he is asking over there. And what he is saying here, label the 3 subatomic particles in the diagram over there. We know that in the nucleus, the protons and electrons are available in the nucleus, protons and neutrons are available. And the amount of proton is exactly equal to electron in the shells over there. Let's see over here. 1, 2, 3, 4, and 5 electrons are there. So it means 5 protons should be there. If I look at the white one, 1, 2, 3, 4, 5, 6. So 6 white one is neutron. And the 5 black is a proton, which are present in the nucleus. And the subatomic particles which are revolving the nucleus are called electrons over there. All right. Use the information in the diagram, complete the table of this element over there. Here sub mass number is protons plus neutrons. So 5 protons, 6 neutrons, 5 plus 6 is equal to 11 is the mass number. Group number means outermost shell electrons, 1, 2, and 3. These are 3A group over there. 3A group is being taken over there. After that, period number. How many shells are there? 1 and 2. 2 shells are there, so period number is 2 over there. Electronic configuration. Electronic configuration is first shell 2, second shell is 3. So it is 2, 3 over there. Give the name of the element. So with the atomic number 5, we will have to go for boron. I will show you here that this is the boron with 11 isotope mass over there, 5 protons, 5 electrons, 6 neutrons. So it is boron. It is boron over there. It is boron. B511. So this was your question number 1 over there. Let's move to question number 2. A small piece of lithium is added to a trough of water over there, where he is saying that state 2 observations made when lithium reacts with water. So it will be giving us fizzing bubbles. Fizzing in the form of bubbles are like that. Fizzing or bubbles are produced. Bubbles are produced over there because this is the metal which shows the very fast reaction over there, and fizzing or bubbles are produced, and after that he will say it gets smaller. Lithium gets smaller in size and smaller in size, and later on is going to disappear completely. and also disappears over there. After that, he is saying what are the products of the reaction? Lithium hydroxide and hydrogen is produced. Yeah, he is right here because whenever I say lithium is going to react with water, it is producing lithium hydroxide plus hydrogen gas should be released over there. So option A is fine. Lithium hydroxide and oxygen can never be produced. Lithium oxide and hydrogen, no. Lithium hydroxide should be produced over there. Lithium oxide and oxygen is not possible for this reaction over there. After that, what he is saying here, after the reaction is complete, a few drops of universal indicator are added in the solution in the trough. Explain the color and pH of the solution. If we look towards the color for lithium in the ion section over there, then I will say it will be little bit the color. If you remember about the ions detection over there and the solution format here, the color of the solution will be purple or blue. Solution will be blue, or purple over there. Where we can say if it is purple or blue, then pH will be, because it is hydroxide, it is just like a base, which should have its pH to be shown by universal indicator in the form of alkali and alkaline solution over there. Then I will say here it will have the range of pH from 10 to 14, a little bit a strong base over there. Give the formula of the ion responsible for this pH. That will be hydroxyl ion, which is produced by lithium hydroxide over there. After that, he is saying lithium ions can be identified using a flame test, okay, by burning it on the flame over there. And here he is saying which color indicates the presence of lithium ions. Lilac, orange, red, no, only yellow. Yellow will be the color of the ion, which will have, we can say, showing that it is lithium over there. Remember that lilac, orange, yellow are not should be taken over there. Only red is perfect. Yellow is also not. Yellow is being produced with the help of sodium metals or like that. Red will be fine. Red will be the ion detection for this one. This is the correct answer over there. Let's move to the next over there. What he is saying here, a student uses paper chromatography to investigate the dyes in 5 different inks, W, X, Y, and Z. The chromatogram, okay, X, Y, and Z means U, V, W, X, Y, and Z. Z is showing the comparison with Y also when some drop down and these drops are shown. Okay, all right, let's check what he is saying. Explain why the start line on the paper is drawn in pencil rather than in ink. Because ink would dissolve, because ink would dissolve into the solvent over there, into the solvent, and chromatography drops will also be taken, while the pencil would not dissolve in solvent. While graphite pencil would not dissolve in water is being taken into account. And ink would travel, run, and produces, we can say, different colors over there. That will be a problem for the main section. And so we will say ink would travel. Ink will travel on the chromatography, and that can damage the results over there. Explain why 2 inks contain the dye that is most soluble in the solvent. Which two inks contains the dyes that most soluble? So remember that if I look at the chromatogram over there, which has given the unique values over there. Unique values are being given with the help of, if I look towards X, this is being shown in the equal form of W over there. V is not showing any capillary action to pile up over there. X is showing unique values. And Z is also showing all the values over there. Y is showing the deviation a little bit over there. So I will say here, as they have traveled the maximum distance, like X has got this whole distance to reach here, and Z has got this distance. Maximum distance is traveled by both of them. And here I will say X and Z. Most soluble, X and Z are most soluble as they have traveled the maximum distance over there on the chromatogram. Explain how the chromatogram shows W contains only one dye and V contains more than one dye. W contains one dye and W contains one dye because there is one spot over there, and on the other end V is not traveling even a single distance, more like that. So here explain the chromatogram shows that W contains only one dye. Then we can say because it produces for W, because it produces only one spot, so it is having only one dye. On the other hand, V, as I said, V is not traveling any distance. Then I can say maybe V is insoluble. Insoluble. So it is not traveling even very little distance. Then I can say here it may contain more than one dye as it has not moved or separated over there. It has mixture of dyes, mixture of dyes, so it didn't travel. By the capillary action on the chromatography paper. Calculate the RF value of the dye in W. Okay, in W. If you will use your, what I say, on the paper, your meter rule, then take this distance traveled by solute, and this whole distance from here, if I change the color so that you can properly understand over there, take this distance of W and the distance traveled by the solvent completely over there. Then by getting both of these values, by taking their ratio, you will get RF value. And I have done it on hard copy paper and I got those values. Distance traveled by solute was 2.2. 2.2 millimeter, 22 millimeter and 2.2 centimeter over there, centimeter. And the complete distance traveled by the solvent was 6.9 centimeter. And if I take its ratio, let's wait over there. Fraction introduced, 2.2 divided by 6.9 equals to this, equals to 0.31, means 0.32. 0.32 is the pH value, RF value, retention factor over there on the chromatography. We have got it. Okay, now he is saying calcium phosphate, Ca3PO4, is an ionic compound with the formula Ca3PO4 whole twice. What is the total number of atoms in the formula? So 3 from calcium, 2 from phosphorus, 3, 2, and 4 to the 8 from oxygen. So 8 to 10 and 3, 13. Option C is correct by counting the number of atoms for this molecule over there. After that, what are the correct charges on the ions over there? Ions in calcium phosphate. Remember that this 3 is coming as negative of phosphate ion and this 2 is coming as positive ion on calcium. So plus 2 and minus 3. Plus 2 and minus 3. Plus 2 and minus 3. So option B will be fine for it. Calcium is having plus 2 charge and phosphate is having minus 3 charge over there. Calculate the relative formula mass of calcium phosphate over there. So I will say here that if you remember the masses, no need to check from the periodic table. Or if you remember that, then let's 3 into calcium is 3 atoms, 3 into 40 plus phosphate is 2 into phosphate is having 31. Phosphorus is having 31 plus 16 for the 48. Let's check what is the value over there. 3 multiply 40. 3 multiply 40 plus 2 into 31 plus 48. 31 plus 48 equals to 278. I think so. I have done something wrong over there. Wait. Bracket close. Bracket close. 278 again. 31 plus 4, it is 16. 4 times 64. It is 64. I was putting by 16, 348 like that. Okay, I'm editing it. 64. 310. Okay, what I say here, calcium is having 40, phosphorus is having 31, and oxygen is having 16. So it is 310 is the molar mass of this compound, relative formula mass of this compound over there. Calculate the percentage by mass of calcium uh, for calcium phosphate over there. So for that purpose, remember that calcium were 3 over there. So I'm taking 3 multiply 40 divided by 310 multiply by 100. Fraction introduced. 3 multiply 40 multiply by 100 divided by 310 over there, and you are getting your answer as 38.70, 38.70, which is approximately equal to 39. So it is 39% is the percentage of calcium in this compound over there. Here he is saying calcium hydroxide can react with phosphoric acid to form calcium phosphate and water is released. This is a neutralization reaction over there in which acid and base are reacting to produce salt and water over there. We will have to balance this equation. First of all, if I look, calcium required is 3. So I'm putting it 3 over here. After that, I'm getting 4 hydrogen, 3 to the 6 hydrogen from here. So it means I will have to go 3 hydrogen from here. 9. So I am doubling it also so that I can get even number of hydrogen atoms, because here I can get only the even numbers over there. So that will be 6 with that one. Let's look over there. PO4 is here in the form of double is present over there. So I don't need to any number to be replaced over here. It is only one there. Okay. Butane is an alkane. Why butane is saturated hydrocarbon? Its general formula is CnH2n plus 2, and it is saturated. It is saturated because it has carbon to carbon single bond, which shows it cannot give addition reactions, which shows that they are saturated hydrocarbons. They are saturated hydrocarbons over there. And remember that if carbon to carbon single bond is present, only substitution reaction can be given by the alkanes over there. No one can give addition reaction over there. Okay, let's move to the next question over there. What he is saying there, when butane is burnt completely in oxygen, carbon dioxide and water are produced. Give the chemical reaction for this combustion reaction over there. So remember that butane is having 4 carbons. According to H2n plus 2, it should have 10 hydrogen plus oxygen, giving us carbon dioxide plus water over there. So if I look here, oxygen is present over there. I should also balance this equation over there. If I say hydrogen is 10 over here, and 2 hydrogen are being taken over there. Okay, for balancing this, carbon is giving in the form of odd form, and oxygen should also be taken in the form of doubling over there. So I'm doubling it here. I'm getting carbon dioxide with 2 for the 8 now. And now I have 8 to the 16 oxygen. So I will have to provide here 16 oxygen here, and hydrogen is having 20 hydrogen, so I'm adding 10 here. Now, why I should 10 here? Because oxygen is odd number. Oxygen is 1 over there, so I will have to take even over here. 10 oxygen from here, 8 oxygen, 8 to the 16 hydrogen here, and 26 total. So there is 13 oxygen over there. Always try to balance the equation by a complete number. Never go with the fractions or like that. Okay, incomplete combustion can occur when oxygen supply is limited. One product of the incomplete combustion of butane is carbon monoxide. Give the name of the other product for this. That can be the carbon, pure carbon with no oxygen over there will be the product when incomplete combustion is going to happen over there. State why hydrocarbon monoxide is poisonous in human. Then we can say carbon monoxide reduces the capacity of blood to carry oxygen because carbon monoxide reduces the capacity of lungs to carry out oxygen, carry out oxygen over there. Okay, C4H10 exists in 2 isomers. What is meant by isomers? Isomers, if I give the proper definition, I can say isomers are the compounds of a molecule, molecules of a compound, molecules of a compound which have same molecular formula but different structural formula are called isomers over there. Here he said, draw the two isomers. As I know that there are four carbons in butane over there, and I am writing only by filling up their hydrogens at all the carbon atoms over there. This one, this one, this one, this one, this one, this one, this one. H, 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 H. Okay, this is N butane. After that, one, two, three, and four. And it is H, 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 and H over here. Three bonds of carbon are done. Fourth is giving hydrogen. One, two, and three. One, two, three. One, two, three. And it is called isobutane over there. So these were the two structure formulas of isomers, displayed formulas I have drawn for you. So this is the way how to draw the displayed formula. Explain why hexane has higher boiling point than butane. The reason behind that, the molar mass or molecular mass of hexane is larger molecule and longer chain over there. One reason, hexane has longer chain as compared to butane, because that is our only four element, and stronger intermolecular forces between the molecules can also be the reason. Stronger intermolecular forces are available over there. And in the last, I will also say here that more energy to overcome the forces. More energy is required to overcome the forces of attraction over there. Okay, let's move to the next question over there. Here he is saying that when iron rusts, iron oxide forms, states two conditions. Very easy for this one, go for oxygen presence into the environment, and there should be humidity or water should be present near the surface of iron. Then rusting can easily happen over there. What is the name of process used to coat iron with zinc over there? Then we can say that it is galvanization, like using electricity plating, electroplating should be done over there, and that should be taken by electricity in the form of cathode and anode and electrolyte, and electricity is going to flow through them. Then it should be taken into account for this formation. Which is the correct order of reactivity from these four metals over there? Copper, iron, zinc, aluminium, copper, iron, zinc over there, and he is saying over there. Okay, first of all, he most reactive should be on the left, so it should be going towards aluminium. Most reactive it should be. This can be this one, or this one. Zinc should not be taken. After that, there should be zinc. After that, there should be iron and copper. So option C will be perfect. Why I said so? If you have the remember the reactivity series, and then you can easily judge this. And there is a table on the book formed over there. Try to remember that table over there. You will be easily memorized, inshallah. Describe the test shown for Fe+3 over there. Fe+3 ion is basically, I can say here that Fe+3 ion and Fe+2 ion is also available. This gives the dirty green color, and this other one, this gives dirty green. and +3 gives the brick red color. Brick red color over there. For this one, for the test, which should I take? I will say here add sodium hydroxide solution. Sodium hydroxide solution. Then what will be the result? What will be the change over there? A brown PPT will form. A brown PPT will form, which will be the detection that you have got the results from this section of working over there. After that, he is saying a sample of iron oxide reacts with excess carbon monoxide. Okay, iron oxide, Fe3, Fe2O3, 3CO, Fe and CO2. Explain why this is a redox reaction over there. If I just observe here, if I break this ion into this over there, what is basically happened? Fe plus 3 and O minus 2 is going towards the produce this Fe with Fe in the form of 0. It means it is gaining the electron over there. On the other and which we say, if I look the loss of oxygen from here, loss of oxygen is called a reduction over there, and carbon monoxide is oxidized to carbon dioxide. It is oxidation. So it is oxidation, and this is a reduction. So both oxidation and reduction are occurring in the same reaction. So I will say it is a redox reaction as Fe2O3 is reduced by the loss of oxygen into iron, and carbon monoxide is oxidized into carbon dioxide. So both overall are acting or performed in the same reaction. So it is called a redox reaction over there. All right, what is he saying? Calculate the minimum mass of iron oxide needed to produce theoretical yield of 28 gram of iron over there. So for this one, I will say here, first of all, calculate I will say here, amount of iron over there, how much in moles it should be required over there. As he said, 28 gram. And if I look towards the iron mass over there, then I will say it is 56. So I will say number of moles is mass in grams over molar mass. If you consult with the periodic table, you will get the molar mass of iron in the form of 28 over 56. If I just do by table, I will get 0.5 moles of iron are being produced over there. Then I will say here, as I have to been taken from Fe2O3, means double iron is producing single iron over there. Then I will say here 0.5 mole should be divided by 2, 0.25 moles are required by that process. Then I will say how many in mass in grams of this Fe2O3 I should take. Then I will say mass in grams is equal to molar mass multiply number of moles. So it is 160 multiply 0.25. Let's go towards it. What should be done? 160 multiply 0.25 equals to 40. So it is 40 gram is the mass of iron oxide which should be required for this calculation. 40 gram. He is saying the actual yield of the iron of this sample is 21. What is the percentage of the yield? So 21 divided by 28 multiplied by 100. 21 multiplied by 100 divided by 28. 7374. 3 by 4 multiplied by 100. 3 by 4 multiplied by 100. Let's check what is there. 3 divided by 4 multiplied by 100 will give you 75. So it is 75% is the yield of this reaction over there. Okay, here he is saying a student does an experiment to determine maximum temperature change when sulfuric acid reacts with sodium hydroxide. All right. Complete the chemical equation of this neutralization reaction because acid and base are reacting. Salt and water should be produced over there. Then for this process, I will say here Na2SO4 is sodium sulfate is going to form and water is should be released over there, and 2OH and H2 is making 2H2O because two hydrogen is coming from here and two hydrogen is coming from here. So I wrote the balanced chemical equation over there, and SO4 is only one time and sodium is doubled and Na2 is balanced over there. Okay, here he is saying that this is the student's method. Step 1, add 50 cm³ sodium hydroxide to a solution to a glass beaker. Record the initial temperature of the sodium hydroxide solution. Add 5 cm³ of dilute sulfuric acid. In the start, he is taking NaOH, and now he is adding 5 cm³ of H2SO4 over there. Stir the mixture and record the highest temperature reached over there. Okay, the student repeats step 3 and 4 until a total 40 cm³ of acid has been added. Explain one way the student could improve the accuracy of the experiment. So he should use, I think so, he should use something which is not allowing the heat to be lost over there. So I will say here, student should use, student should use poly polystyrene cup over there, styrene cup instead of beaker, because when it is heating up, it can be dangerous. And otherwise, he should use if he still wants to use a beaker, then he should use a lid over there, or he should do so because less heat is lost, so that less heat is lost so that you can get more accurate values over there. Okay, here he is saying that some values are given. All right. The volume of the acid in cm³ 0, 5, 10, 15, 20, 25. All right. Then he is saying temperature of the mixture is 0, 21, 22.3, 23. Now he is saying plot the results on the grid. 21, 22.3. 25, okay. 10 and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 20, 25. It means it is 5. Okay, for 1 degree, I will have to go for 5. 1, 2, 3, 4, 5. So this is my first point. After that, what is he saying? Go for 0 is 21. After that, he is saying 5 for 22.3. 5, 21, 22.3. It should be coming here. After that, for 10, 23.8. Coming like this. After that, 24.4. 24.4. 26.5. 25, 26.5. 1, 2, 3. After that, he is saying at 30, 28, 25, 28. 25, 26, 27, 28. At 30, 28.5. And 28.2, 27.9. 28.2, 27.9. Okay, this is the graph plotting over there. Draw a circle around the anomalous results over there. So these are the points over here. And if I join all of these points over there a little bit, by drawing this best fit line, anomalous points are 1, 2, and 3, which are totally deviating from the original values. Draw the straight line of best fit through the first 6 points over there and ignoring the anomalous result. Draw another straight line of best fit through the last 3 points over there. First 6 points. 1, 2, 3, and last 3 points. 3, 1, 2, 3, 4, 5, 6. And last 3 is going to be taken like this. This is the best fit near I start touching to these points approximately over there. Then what is he saying? Make sure that these two lines cross. Yeah, this line is crossing like this and this line is crossing like this. The point where the lines cross show the volume of acid needed exactly neutralize the alkali of maximum temperature reached. Use the graph to determine these values over there. So what is this value of temperature? Temperature is 25, 26, 27. So it is approximately 27, I can say over there. Maximum temperature is 27 degrees centigrade. And what should be the volume of acid over there? Then it is, having its value approximately 30 cm cube. If you try to draw exactly, then maybe little bit deviation to the values can be observed over there. Explain what might have caused an anomalous result. That can be any sudden mistake, or we can say here, which he should keep in mind. He did not stir the mixture, did not stir the mixture over there, or I can say here, he took the temperature too early like that, took the temperature value of on the meter too early over there. So this is the way how we can say we should be much more familiar with these readings and workings over there. Okay. Diamond and graphite are two naturally occurring forms of carbon. They both have the giant covalent structures. Explain with reference to its bonding why diamond has high melting point over there. So I will say here, due to tetrahedral structure over there, I can say here that covalent bonds are strong. Covalent bonds in diamond are strong. On the other hand, I can also say about it that many covalent bonds need to be broken down. Many covalent bonds need to be broken down for high melting point to be broken down over there. I can also say here that a large amount of heat energy is needed to break bonds. A high energy is required to large number of bonds to be broken down, to large number of bonds over there. So always remember, when high melting point of diamond should be taken into consideration, remember that one thing, covalent bonds are present and need much more higher energy to break them. Explain why graphite is soft and is conductor of electricity by the reference to refer to the structure and bonding in your answer over there. So we will say here bonding is, first of all, I will say bonding is covalent bond. Bonding is covalent bonds available over there, and graphite is having layers structure, like it's graphite lies in the form of layers, in the form of layers which can slide over each other, which can slide over each other. And when they are going to show the slide over each other, so they are soft. They are soft enough, and they have free electrons present between the layers, present between layers, which help for electricity transfer, which makes them conductor to electricity over there. And remember that in the diamond, they are making every carbon with 4 carbon more. But in graphite, 1 carbon is bonded with 3 carbons over there. And 1 electron is being considered as free electron for helping towards the electricity over there. The question is about organic compounds. Chloroethane, ethene, okay, is a covalent molecule which is being given, is used to make polychloroethene. Means now he is talking about polymerization. This is the displayed formula of chloroethene. Draw a dot and cross diagram of chloroethene over there. So I am saying here that 1 carbon and second carbon is present, and they are producing 2 like this. And I am taking here cross, cross, and cross and cross. I am making here a bond because of my hydrogen over there to be shown like this, that it is showing hydrogen like this. It is showing hydrogen like this. It is showing hydrogen over there. It is showing hydrogen over there. So this is dot and cross diagram between carbon by showing the double bond between them, and hydrogen is attached over there. Always remember, outer shell electrons are taken. Even though carbon is having 6, 12, first shell is having 2 electrons, uh, 2 electrons, and then 4 electrons. In the first shell, there is 2. In the second, there is 4. I have used only the outer shell electrons over there. After that, what is he saying? Describe in terms of electrostatic attraction what is meant by covalent bond. Then according to definition, you can also go with that. The bond which is formed due to mutual sharing of electrons. The bond which is formed due to mutual sharing of electrons is called covalent bond. And they have much more stronger forces of attraction like that. It is attraction between nuclei and pair of electrons. Nuclei of protons and neutrons over there are going to attract the electron pairs, electron bond pairs. Should be being taken into account for this simplification. Chloroethene is a monomer. Draw the displayed formula that repeats its unit. Always remember that whenever we are going to do such activity, I will break this double bond and make a bond outside. CCCl only on the one side. Oh, yes, then it should be having a Cl over there. Cl is here, 1 is here, 2, 4, and 6. Really sorry. I was just taking ethene, not chloroethene. Now I will have to go for chloroethene. C, single bond C with Cl with C with C with H with H with H, and I'm making this bond here and this bond here. This is my monomer, which is showing the complete longest structure over there. This is the way. How should I go with it? Polychloroethene is non-biodegradable. There are two main methods used to dispose the fluorochloroethene. Describe one problem caused by each method over there also. So we can say here disposal of polychloroethene in landfill. Landfill should be used to dispose or to destroy is landfill. But the problem with the landfill is that it takes up space and take very long time to decompose or dispose over there. And after that, I'm taking the second method like burning of polychloroethene. Burning. If burning is done, then definitely there is hydrogen chloride produced. Hydrogen chloride gas will be produced, which is very poisonous, and toxic gases are produced. Toxic gases are produced over. Okay, here he is saying an organic compound contains this percentage by composition. Calculate the empirical formula. The best way to go with it is write down the percentages 22 over 12, empirical formula calculation, okay? And ratio 4.6 over 1, ratio 73.4. And for bromine, if I tell you the mass over there, that is 80 over there. You can check it from the periodic table. By getting these ratios over there, then approximately I will say here, first of all, I will have to go for their calculation of the functions over there. Then I will say, let's go for their calculation. It is 4.6 as it is. It is 22 over 12. 22 over 12. 22 over 12. 22 divided by 12 is equal to this is equal to 1.83. After that, 73.4 divided by 80. 73.4 divided by 80. 73.4 divided by 80 is equal to this is equal to 0.9175, 0.92. 0.92. So this is the smallest one, divide by 0.92, divide by 0.92, divide by 0.92, and get their ratios in simplified form over there. 1.83, 1.83 divided by 0.92 equals to this is equal to 19. So it is, I'm taking 2 over here, ratio 4.6.92. 4.6 divided by 0.92 equals to 5. So it is 5, and we know this is 1. So our formula will be C2H5Br. This is the empirical formula. Now he is saying ethane and ethene undergo different types of reactions with bromine. Describe the difference between these two reactions. Ethene can go addition reactions, while ethane can go towards substitution reaction. For example, ethane is having CH3 single bond CH3 is going to react with Br2 over there. What is happening? CH3 C2H5 Br plus HBr. On the other end, CH2 double bond CH2, this is ethene, is going to get Br2. What will happen? It is going to produce C2H4Br2 as its molecular formula. If I draw its structural formula over here, then I will say it will give me CCHHH. It will also have Br here and Br here. So this is the addition reaction. And the other one is substitution reaction. Substitution reaction over there. Okay, this was your whole paper, which you should try. Okay, this is the question number 10 also available over there. All right. Now he is saying a student uses this apparatus to investigate okay, a student uses this apparatus to investigate the energy content of different fuels over there. Copper can, thermometer, water, split burner with the liquid fuel over there. Pour some of the water into the copper can and record the mass of the spirit burner and the fuel. Measure the initial temperature of water. Place the spirit burner and under the copper can and light up this. Stop heating when temperature reaches 30 degrees centigrade. Record the new mass. Okay, in different cases he is using different fuels over there. Student repeats. Explain two variables in the student should control to make this valid test over there. So I will say here that it should have same volume of water. Volume of water should be taken into account. After that, he can say here same amount of fuel should be taken. Same amount of fuel should be taken so that he can easily observe over there. On the other end, for second pair, I can simply say here that he should stir the water. And he should also go for so that the temperature is uniform, so that the temperature of whole water can be uniform over there, means equally distributed in whole water. And for the last one, I will say here that he should make sure that the spirit of burner is the same distance from the copper can over there. Same distance of burner from copper can. I try to tell you about all possible situations where he can should link over there. So try to be focused by that formulas over there. Okay, here he is saying the change in temperature in the form of delta T is given by using these two, and the volume is given, and mass is given, and initial mass is given. So change in masses is available, and you will also have to go for the calculation. Okay, here he is saying that 1 cm cube is 1 gram, 4.2 is specific heat capacity. Okay, we know the formula Q is equal to mc delta T. If I take mass over there, then mass is being taken as he's in the start. He said that it should be taken as 100 volume cm cube of water. So 1 cm cube for 1 gram can be taken there. So m is 100 gram. C is 4.2 and delta T is 30 minus 18 is equal to 12 over there. Hundred multiply 4.2 multiply 12 equals to 5040 in joules. 5040 in joules will be the energy. 5040, which is approximately equal to 5,000 joules over there. In the next part, he is saying calculate the enthalpy change delta H in kilojoule per mole when MR for ethanol is 46. Include the sign in your answer also. So if we look towards mass of ethanol over there, then it is 38.52 to 38.29. So 30 mass of ethanol I am talking. Ethanol 38.59 52 minus 38.29 minus 38.29. Okay, 52, 12 minus 9 is 3. 4 minus 2 is 0.23 gram is the mass. And if I want to get its number of moles, then I will say mass in grams 0.23 over MR is 46. And then I will say here that the number of moles which I will get, 23 times 46 is already available over there. It is 1 by 2. So I will say it is having its number of moles as 0.005 moles. After that, we can say here, because I have the energy that was 5050, 5040, that was I have taken in the previous part over here, 5040. Then I will divide this with the number of moles. 5040 divided by 0.005. If I remove this, it means 2 zeros are coming up, 3 zeros are coming up, and dividing by 4, by 5 over there, and I will get 1008. 1008 with 1 and 2 zeros. No, but 3 zeros, because it is taking its decimal till here. And after that, I am saying I will have to convert it into joules, kilojoules. So dividing it by 1000 also. So 1008 will be my energy in the form of 1008 kilojoule per mole. After that, as this was the combustion reaction, So it should be lost into the environment, and negative sign of the enthalpy should be present over there. Okay, this was your whole paper. And at the end of this paper, I will suggest you that kindly subscribe my channel and like the videos for the whole preparation of your all exams related to physics, chemistry, and mathematics. And try to be connected, like and share the videos. And if you want any explanation, again, you can give me the comment on any video over there in the question number. I will explain that solution also. Thank you so much for today, and see you tomorrow, guys.